For those of you that remember some of the challenging problems that you had to do during the school year for thermochemistry were the heating and cooling curve problems. Luckily, since you do not have to solve one of them on your final exam, you're not going to have to go through and actually do the math for an entire heating and cooling curve. However, for the final exam, you do need to be able to understand what is happening at the certain spots on a heating and cooling curve. So that's what this little tutorial is going to show you, and then we're also going to go into a little bit of kinetic energy stuff because some of that shows up on the final as well. So here, let me speed this up a little bit. Heating and cooling curves. Now, what we tend to think happens, and this is just from very standard what you see if you are boiling some water. In labs, you see this all the time. What we see is that as we heat something, the temperature rises. So if you had to guess what a graph would look like, is something like that. A direct correlation. The T stands for the temperature. So as our time passes, our temperature continues to rise. Now the reason that we see that is because, again, the most common way you see this is when you're boiling water. And so you are starting with your thermometer in water, and you are ending with your thermometer still in the water. So you're not actually looking at a heating and cooling curve from a solid to a gas, you are just looking at the water portion. So when you see it increase in temperature like that, you're just looking at water. When we look at heating and cooling curves, we are looking at something going from a solid to a gas or a gas to a solid. Okay, so we're looking at when the phases change. What a heating curve, the first one I draw out here is a heating curve. What it looks like is it increases in temperature. So we could say that if this is, let's say this is for ice and water and steam, so let's say we're working with water, then where this would start to level off would be right at 0, because that is the melting point or freezing point of water. So it would go up, level off, go up, level off, and go up again. The second place where that would level off, again, if this is water, this would have to be 100. Now we're going to label these spots here. We have A, B, C, and D. You may want to have this written out because it is important that you understand what's happening at the different spots on a heating and cooling curve. And we're just going to quickly walk through them. So A, what's happening at spot A, this is when it is below the melting point. So that's when it is a solid. The important thing to see I want to go through real quick here and write our A, B, C, and D out so that we can talk through these. The important thing to notice at A is that it is increasing in temperature. Okay, so it is a solid phase and it's increasing in temperature. Now what happens, and this is an important thing for you to know, when we are heating something, the temperature is not always increasing. Sometimes that energy that's being put into the system is being used to change the phase. Now think about what happens at a phase change. You're going from in this case, we're going from a solid that's very close together to a liquid that's further apart. Those molecules being pulled apart takes energy. So that energy that had been used to increase the temperature is now being used to pull the molecules apart. So at A, we have an increase in temperature. There's the solid, when it's a solid. At point B, that's a phase change, that's where it's melting. At point C, that's where we have a liquid. Again, notice that I write in there that the temperature is increasing. At D, it's where it is boiling, because again, our phase is changing. And at E, we are increasing in temperature at the gas phase. Okay? The big thing that you need to be able to recognize come your final exam time is that at A, C, and E, that's when our temperature is changing. Okay, remember that temperature is also associated with kinetic energy. So at A, C, and E, that's when our kinetic energy is changing. At B and D, that's where our phases are changing. Okay, so why don't you guys here, I have drawn out a cooling curve. Why don't you pause real quick and try to figure out yourself. Again, I'll label A, B, C, D, and E. Decide what is happening at each spot and decide when you have a change in kinetic energy and when you have a phase change. Okay, go ahead and pause and do that real quick. Okay, what you should have come up with is at point A, C, and E, that's where the kinetic energy is changing. And at points B and D, that's where the phase is changing. So since this is a cooling curve, A is a gas, B is when it is condensing, C is a liquid, D is when it's freezing, E is when it's a solid. Again, a reminder that kinetic energy is directly related to the temperature. So as we say the as we say the temperature decreases, that means the kinetic energy decreases. On the heating curve, that of course would have been opposite. And again, the last topic here I want to hit one more time is the kinetic energy. You need to know, for the final exam, you need to be familiar with this. The same substances at the same temperature have the same kinetic energy. It doesn't matter if you have a piece of copper at 70 degrees Celsius and a piece of cloth at 70 degrees Celsius. If they are at the same temperature, those molecules have the same kinetic energy, independent of the substance that you're working with. Another way that you might see this is in terms of phase changes with kinetic energy. So that first thing there, that's one idea of kinetic energy. The second thing, and you will see this again when we get to some of the equilibrium stuff also, but we have our phase change here, melting. You need to be able to determine whether the kinetic energy is increasing or decreasing for each of these processes, for each of these phase changes. Now obviously when it's in a heating or cooling curve, that's a little bit easier because you're actually seeing that graph and you can see what is happening. However, what you can do here is we can look at what is happening in the phase change. So when we're going from a solid to a liquid, that means that it is gaining energy, right? Solids have very low energy, liquids have higher energy, so it gains energy. And there's a few things you can figure out from that. One is that would be an increase in the kinetic energy, and the second is that it is an endothermic process. Okay, again, we'll hit this again later, but it is important that you can look at any phase change and determine what its starting phase is. So here's its starting phase, what its ending phase is, and what that means. That means that it has gained energy, because it went from low to high, which means that it increased in kinetic energy. And again, since it's gaining energy, energy is entering system, which means that it is endothermic. And that should just about, tomorrow you will get something where you will see a lot more on endothermic and exothermic, because those show up on the final exam a lot of times. This was, I know, a little bit scattered, but we had to hit all of the random points for the final exam to help us round out thermochemistry a little bit.